Okay, so I hope you can see my screen now. So first thing I want to tell you that when you are doing the microscopy, okay, and you put your slide on the microscope stage for imaging, how you should adjust the exposure time and the intensity of the light source. So whether you are going for the wide field imaging or the confocal imaging, okay, but in any case, you have to adjust your laser power or the intensity of your fluorescence light, okay, and the exposure time. So how you can select that thing? So here you can see two images, right? This one is captured with one exposure time, and this one is captured with very high exposure time. So what difference you can see here? The difference is that when you capture an image with a very high exposure, you can see that some of the pixels are saturating. Okay. So this kind of image is not good for the quantification. Quantification means if you want to measure the fluorescence intensity, you should not use this kind of image where the pixels are saturated. You should always use an image where the pixels are not saturated. Now, how to confirm that this image has pixels saturated or not saturated? So whatever the microscope you are using or whatever the software that you use for image acquisition, that software gives you this kind of a graph, which is known as histogram of pixel intensities. Okay. So all the softwares will show you this kind of graph when you are in live mode, and even once you capture the image, then also you can see this graph. Okay. But in the live mode, if you see this graph, you can change the graph parameters. Okay. By increasing or decreasing the exposure time, or by increasing or decreasing the light intensity. But once the image is captured, then you can just see that how this histogram of pixel intensity is there for that image, but you cannot change it, right? Because that is already a captured image. So now you cannot change it. So while capturing the image, what you should consider? So see, this is the histogram of pixel intensities, and you can see that on the x-axis, the pixel intensity values are there. That means 0 represents the dark pixel, and this side 1 is the highest number. So 1 represents the brightest pixel. Okay. So let's say if this is a 250, this is a 8-bit image. So it has 256 gray levels, right? So 0 represents the dark pixel, means the completely black pixel, and 1 represents completely bright pixel with having the fluorescence intensity of 255. Okay, because there are 256 shades for 8-bit image. Okay. So if any pixel value goes beyond 1 or at 1, so that is known as the pixel is saturated. Okay. So here you can see your most of the pixel on the y-axis, the counts of the pixels are there, right? So most of the pixels have the fluorescence intensity value between 0.0 to 0.2, right? And then some of the pixels are bright also. They have the fluorescence intensity value of up to 0.6 pixel intensity, right? So generally, this is the ideal range. You should make sure that this graph remains on the left, and there is some tail which goes up to 0.6, and some portion should remain empty also. So it is recommended that you should only use 50 to 75% of the range of this graph. So 50 to 75% means at least 0.5 to 0.75. Okay, means you should only use, your pixel should be within this area only. It should not go above 0.8, because if you increase the fluorescence intensities of your light or the lasers, or if you increase the exposure time, then you will see that slowly this graph will move towards right, and eventually you will see that some of the pixels are saturated. And if the pixels are saturated in your image, this image becomes useless for any kind of fluorescence intensity measurements, because some pixels are saturated. They cannot show the real pixel intensity value, right? So that's why none of your pixels should saturate. All the pixels should remain within this limit. Now, how to set this thing? So while you set this thing, First, you put your control sample on the stage, okay, or the sample from which you expect the maximum brightness, okay. So first you adjust the fluorescent light intensity and the exposure time for the brightest sample, keeping at least 25% pixels or pixel intensities available, okay. So you should only use 50 to 75% of this pixel intensities values, because the next sample that you are going to image, that may be brighter than this, okay. Suppose you are comparing two samples, wild type versus mutant, or healthy cells versus some disease cell line, right? So it is possible that this protein expression may be higher in the disease cell line compared to the control, okay. So if you set the exposure time for control sample, then if this 25% pixel intensities are remaining, then maybe when you will put your disease cell line, which has a brighter fluorescence, so it will have some values on the x-axis, right? Means it, at least it can go up to 1 or even above 0.8, because those images are brighter than your control sample, okay. So that's why always it is recommended that while setting the exposure time or the fluorescence light intensity, you should only use 50 to 70% of the range. You should not use the full uh, range for pixel intensities, okay. So once you capture a good image, then the next step is, okay. So here I will show you one particular example. I am opening this image in ImageJ. So this image is a 4D image. It has a XYZ plus multicolors. Okay. So I will ask the ImageJ to open it as XY channel Z and time. There is no time, but I will open it as a hyperstack. So you will see how that image will open. Okay. So I open this image, and what I am seeing here is everything blank. I'm not seeing anything, right? So I'll explain you how to interpret this image. So first, see here, you can see a small panel where something is written, right? So let us understand what is written. So first it is showing that C means channel. And this image has 4 channels, and currently we are on the first channel. Now how to change the channel? Let's say if I want to change the channel, then at the bottom you can see the scroll bar with C, right? So there are 4 channels. So this scroll bar has 4 positions. So this is first position, this is second position, this is third position, and this is fourth position. Okay. Still you are not seeing anything here. Why? Because this is a Z stack image and it has 45 Z stacks. And you are currently visualizing the first Z stack. That means the bottom of the cell you are seeing. So it's the bottom of the cell. That's why you are not seeing any signal. But first thing, you should keep to the, you should bring this Z stack to the center of the Z position, right? So I will move the Z stack here, right? By scrolling this bar, and I will come to the image number 22 or 23, which is considered as the middle, because there are 45 Z steps. Okay, so 22 or 23 numbered image is the middle one. So I brought this scroll bar to the middle. So now I can see my signal. Now I am seeing this fourth channel. Okay, so currently you can see the fourth channel is active. So I can go back to third channel, second channel, and now I can see some signal here and there, right? And first channel. So what is my next task? First thing, I have to adjust the brightness and contrast so that I can see my image, or I can see my structures fluorescently labeled. Okay. So in ImageJ, there is a tool known as brightness and contrast adjustment tool. So you can find that tool here. Under the image menu, go to adjust and brightness and contrast. Okay. So I'll open this. So it will open this kind of a window. Now for each channel, I have to individually set the brightness and contrast. So now I selected the first channel, which is here, and I'll push this maximum towards this side so that my structures are visible. So here what I want to see this bright foci, along with that some faint foci also. This is a single molecule fish image. So the bright foci are the transcription sites and the faint foci are the single molecules of mRNA in yeast cells. Okay. So this is how I adjusted the brightness and contrast so that I can see the information that I wanted to see. Okay. And now if you will move it in Z-Stack, you can see that it looks like this. Again, I'll put the Z-Stack at center. Okay. I'll go to the next channel for the brightness and contrast adjustment. So in this channel, I will push this bar this way and I will adjust the brightness and contrast in such a way that I can just see these 2 dots per cell. Then I'll go to the third channel, and here also I'll adjust the brightness and contrast. And then I'll go to the 4th channel, and here I'll also adjust brightness and contrast. Okay. So this is how my 4-channel image should look like. Now, as I mentioned that generally in the fluorescence microscopy, a monochromatic camera is used, right? So camera has captured the image as a grayscale image. Okay, it doesn't know which dye has been used and what is the color of that dye. So now we have to give the pseudo color to this image. Pseudo color means what are the color of my interest that I can give. So generally this nuclei were stained with DAPI, and DAPI dye has a blue color fluorescence, right? But I don't want to see this nuclei in blue color. I want to see them in yellow color. So what I will do, I will go to this LUT tool in the image J, that stands for lookup table. Okay. And there are several colors here. So I can select any color of my interest. Let's say I want to make the nuclei yellow in color. So I selected yellow. Then I will go to the 3rd channel and I want to see this protein in red color. So I'll select color red. Then I'll go to 2nd channel. I want to see this protein in green color. So I'll select green, and I'll go to the 1st channel and I want to see this single molecules of mRNA in let's say magenta color. Okay. So this is how you can give colors to your different channels. Okay. So this image has 4 channels, 4 different colors and 45 Z stacks. Okay. So we gave the color also. Now suppose, let's say from the last channel, here you are seeing the nuclei. And if you want to quantify the fluorescence intensity of each of these nuclei, okay. So how will you ensure that none of the pixels are saturated in this image? Because before going for the fluorescence intensity measurement, you have to ensure that this image is acquired with proper exposure time and all, so that there is not a single pixel is oversaturated. Okay. So I will search for the histogram tool because I want to see that histogram of fluorescence intensity. Okay. So here I can write histogram and I can run this tool, histogram. It will ask me include all 180 images. Why 180? Because for one channel, 45 images. So there are 4 channels. So total 180 images. So I will say yes. Okay. And I'll put it on live mode. Live mode means what are the things I will change? It will be reflected here in the histogram. And you can see that for this particular channel, we have the fluorescence intensity between 0 to 14,386, 385 gray levels. Okay. So first you see this image is a 16-bit image that you can get to know from here. Here it is written, this image is a 16-bit image. So it has been captured with a 16-bit camera, and 16-bit image has almost 65,000 gray levels, right? We already discussed this in one of the theory class that the 16-bit image means it has a gray levels from 0 to 65,500 something. Okay, so many different gray levels are there. But for this yellow channel, only 0 to 14,385 gray levels have been used. For the red channel, from 0 to 24,354 gray levels are used. For the green channel, from 0 to 32,063 gray levels are used. And for the first channel, 0 to 56,346 gray levels are used, right? So you see that we never reached to the 65,000, which is the maximum capacity of this 16-bit camera, right? So now you can see that most of the pixels are towards the left side, and there is a very thin tail which we are not able to see here, right? So if you ask me that where exactly our data ends, I cannot say that by looking at this graph. So what I can do is I can convert it into log scale. So here is a button for converting this representation into log scale. So if I convert this graph into log scale, then you can see that here my data ends. Okay. So only this many gray levels are actually used. Okay. Okay. Now let us go to the second channel. So here even some pixels have this value also. So if you go to this last bar, you see it has count of 2 and it's a value of 25,675. Here you can see count and value. So what it indicates, there are 2 pixels with a gray level of 25,800. There are 4 pixels with the gray value of 23,546. And as you go towards the left side, you can see that the number of pixel counts increases and the fluorescence intensity values go down. And if you reach to this thing, it will be the value will be 0. Okay, so this is how to interpret this histogram of fluorescence intensities. And before you make any quantitative measurements from the image, you should ensure that your image is not overexposed, okay, by checking this graph. Okay, so you have to check the bit depth of the image, that is a 16-bit image. So that means it has from 0 to some 65,500 gray levels. Okay, so this value should not reach to that 65,000 limit. Okay, it should be within that limit. And if it is within that limit, then this image is quantifiable. Okay, fine. Any question as of now? You can just unmute yourself and ask the question if you have any questions. Okay, now I will open another image which is available in the sample image itself, and HeLa cell. So it's a RGB image, 48-bit. Let me open that. Okay. So this is a 3-color image. Now see, this image doesn't have Z-stack. Okay. It has only 3 channels. The first one is the red channel, second one is the green channel, and the third one is the blue channel. Okay, so there is only one scroll bar is there for channels. And it was also acquired by 16-bit camera. Okay. Now, if I want to do the fluorescence intensity measurement for, let's say, only the blue color, okay, then I cannot do it from this image because this is all three channels merged, right? So from this image, I cannot do the fluorescence intensity measurement for blue color. So first thing is I have to split the channel of this image. So I'll go to image, color, and split channels. So see, it splitted it into 3 channels, blue, green, and red. Okay. Now from these individual channels, if I want to do intensity measurement, I can do that. I can measure the intensity of green fluorescent protein or whatever is the red color protein or the nuclei. Okay, because now the channels are separated. Also, I will check whether these images are saturated or not. So for that, I will open that histogram tool. These images are also captured with 16-bit camera. So the maximum gray level will be 65,000. Okay. So see, for this channel, blue channel, the maximum gray value here is around 2832. So that is fine. Then for green, it's not showing. I will open this again. For green, the maximum value is 1900. Okay. And for red, for each channel, I have to open a separate histogram and lock. Okay, so maximum pixel value is this. So this histogram is for red. This histogram is for green. And for blue also, I'll open another histogram. This is for blue. Okay, so these are these three histogram, and for all this histogram, you can check the maximum value, which is not reaching to 65,000. So all these images are quantifiable for fluorescence intensity measurement. Okay. Now, one more thing that I wanted to show. See, in this image, using this tool, what I'm doing is this is a brightness and contrast adjustment tool. Okay, so using this brightness and contrast adjustment tool, I'm just changing these values, and you can see that by moving this thing this way, I can make this image brighter. Okay, now what will happen? Let's say I have drawn an ROI, region of interest, to measure the fluorescence intensity of this nucleus. Okay, I want to measure the fluorescence intensity of this nucleus. And just by changing this bar, okay, by scrolling this bar, I can see that I can increase the intensity also, I can decrease the intensity also, right? So if I want to show that, okay, this nucleus has a lot of protein, let's say, so I can just show it like this, and I can say that, okay, this nucleus has a lot of protein expressed. And if I want to show that, okay, this nucleus has not a good amount of protein, I can show it like this, okay? So is this the right way? How you will adjust this brightness and contrast? Now, first thing you should know here is, by doing this kind of changes, I am actually not changing the fluorescence intensity of the pixels. Okay. I am just asking the software to display only a few pixels so that I can see the image brighter. Okay. So you see the total, this image has gray value from 0 to 2832. Okay. But by doing this, I am asking the software to show me all the pixels which are between 0 to 983 gray levels, right? And that's why the software is showing me all such pixels. Okay. So by doing this, the pixel intensity value of the image will not change. So whatever the fluorescence intensity you have measured for this nuclei, by keeping it like this or by keeping it like this, it will be the same. Okay, there won't be any difference in the actual fluorescence intensity. And this is perfectly fine for your publication purpose. Let's say instead of showing this nucleus like this, I can just adjust the display, and I can show it like this. Okay, but this kind of adjustment should not create any artifact. Like, let's say if I don't do this adjustment correctly, and if I show this nucleus like this, okay, like the uniform illumination, this is not correct, because actually there is not a uniform distribution of signal here, right? Actually, you should show this nucleus like this. so that people can understand, okay, this has actually some different areas, like this is a very bright area, this is a moderately bright area, and this is some dark area. Okay. So for the publication purpose or for any final reporting purpose, don't over uh, uh, process your image so that the real information is lost and you end up showing some artifactual information. Okay. So be very careful while adjusting this brightness and contrast. Okay. These are all known as linear adjustments. So whatever you are doing, that you are doing across the image. So they are okay for the publication purpose. You can just slightly change them here and there to make the things properly visible and to show the actual details that you want to show. Okay. But don't, if you don't know how much to push this bar, then you will end up showing wrong information. Okay. Yeah, so I think that's it for today. If you have any questions, we can discuss. Any questions? Okay, then I hope you are enjoying the course, and feel free to write me an email, or you can ask the questions on our discussion forum also. Okay. Okay. Thank you for attending this session.